Here we go. 23, it says find the perimeter of triangle ABC, and we see this picture over here. We actually saw this on the quarterly assessment review. First off, of course, identify what it's talking about. Triangle ABC would be right here. Perimeter is distance around the shape. So what I would do is find sides that you can just count the units. So for example, this bottom part of the triangle, I can count the units 1, 2, 3, 4, 5, 6 units here. And then I need the length of each of these sides. I can't really count the units because it's on a diagonal, so I will need to calculate it. I'm going to use Pythagorean theorem. So just sketching out a right triangle, I can use Pythagorean theorem. So for this right triangle, I have 2 units by 3 units. And then I can use Pythagorean theorem to find the length of the hypotenuse, which would be this length here. So 2 squared plus 3 squared equals c squared. And square root of both sides, so square root of 13 equals c, which is that length right there. So you may be able to see that this is the exact same length, or when you sketch out the right triangle and it has the same dimensions of 2 by 3, you'll know that this is also square root of 13. Now from here, we just add those side lengths together to find perimeter. So I'm going to zoom out now and go over here. 6 plus square root of 13 plus square root of 13, and that will give us the perimeter. So then plugging it in the calculator, again zooming out, square root of 13, whoa, that's not what I want. Square root of 13 times 2 plus 6, and I get 13.2-ish. So this equals 13.2. Okay, next. 24, it says find the perimeter of quadrilateral ACDE. Of course, first step, identify what it's talking about. AC, right here, D, E, and just kind of trace it so you can focus on that part. Perimeter is distance around the shape. So I'm going to count anything that I can just count the units. And again, I'm going to zoom in over here. Okay, so for the base here, 1, 2, 3, 4, 5, 6 units. 6 units here. So 6 units on top as well. And then I need to find the length of the diagonal and sketch out the right triangle so I can use Pythagorean theorem. 2 units by 1, 2, 3, 4, 5, 6 units. So off to the side, 2 squared plus 6 squared equals c squared. And then c equals square root of 40. So this length right here, square root of 40. This diagonal is the same length as that, so this is also going to be square root of 40. And then we can add up the side lengths to find perimeter. So over here, we'll do 6 plus 6 plus square root of 40 plus square root of 40. Well, I'm going to do square root of 40 first. Square root of 40 times 2 plus 12. You get 24.65. Okay, next. Find the area of triangle ABC. ABC was the green triangle. Area of a triangle is 1/2 base times height. I wonder if that's on the reference sheet. Let me see if that equation's on the reference sheet. It literally doesn't have area of a triangle on the reference sheet. Yeah, it doesn't have area of a triangle on the reference sheet, so that one has to be memorized, which you probably already know it by now. 1/2 base times height. So the base of this triangle is 6, so 1/2 times 6. The height of this triangle, that's perpendicular height, is 2 units. And then we can solve. 1/2 of 6 is 3. 3 times 2 is 6. So area is 6 units squared. Okay, so like I said, that's the longest problem. Now the rest is actually really quick. So we're going to go back to where we left off yesterday. 19. Okay, so this is the weighted average lesson we did one day in preparation for the quarterly assessment, and here it is again on the exam review. Remember, it's a pretty simple process. You might not remember exactly, but once I bring it back in your brain, you'll probably remember it. So coordinate -6 has a weight of 3, so we're going to multiply those two numbers, and coordinate 2 has a weight of 1. So how we would set this up is -6 times 3 plus 2 times 1. And then we divide it by the weight, so 3 plus this weight of 1. And then from here, -18 plus 2 over 4 is -4. So in terms of studying, that might be one that you practice a few times just to make sure that you can do it on the exam, no problem. Okay, next one. This is also from the quarterly assessment review. It says the endpoints of CD are these coordinates. Find the coordinates of the midpoint and then find the length of CD. Okay, there's actually like 3 or 4 questions on midpoint, so make sure we're good with that. Let's see, we have C is at -2, 4. D is at 4, -4, and then we're finding the midpoint. So if you set it up like this, it's pretty easy to see where the middle is, especially when you have numbers like 4 and -4. The middle would be 0. And then the middle of -2 and 4, that may jump out at you, it may not. If it doesn't, just find the average of those two numbers. So you can do -2 plus 4 divided by 2. So 2 over 2 is 1. So the middle there would be 1. So our midpoint is 1, 0. And then it says to find the length of CD. So it gives you 2 coordinates. If you're comfortable with the distance formula, you could use that. What I would recommend is actually just graphing it and using Pythagorean theorem because there's less errors that happen that way. Obviously, you probably don't have graph paper in front of you, so I'm just going to sketch this out. You don't have to sketch it out. I'm just going to show you. So here's my coordinate plane, -2, 1, 2, 3, 4. This is C. D is at 4. Right here. Okay, here's my segment here. It wants to know the length of that segment. So once you have it sketched out, you can just do the right triangle. And the dimensions here are 6 units by 8 units. And then I can use Pythagorean theorem. So 6 squared plus 8 squared equals C squared. It solves to C equals 10, so that means the length of CD is 10 units. If you weren't able to graph it or you wanted to take a shortcut, I know you guys understand math really well. Something you could do to kind of shortcut this and shortcut the long equation is if you notice the difference between the x's, -2 and 4, there's a difference of 6 there, so that's your 6 squared. And then there's a difference of 8 between 4 and -4, so that could be your 8 squared, and you could kind of shortcut the graphing by doing it that way. Just FYI. Okay, next page. '21, it says T is a midpoint of CD. The coordinates of D are 8, 20. What are the coordinates of C? Okay, so we have our midpoint at 8, 15. C we don't know, and D is at 8, 20. Well, we're fine. Like from the midpoint to D is +5, so in the other direction it would be -5. So this would be 10. And then here with the 8, the middle of 8 and 8 would be 8. So C is just 8, 10. Okay. Next, another midpoint problem. They're giving us latitude and longitude coordinates of Salt Lake City. right here, and your friend lives in Arkansas with coordinates of 35 north and 91 west. You plan to meet halfway, so that would be the midpoint between the two cities. Find the coordinates of the halfway point. So using the same process for midpoint, we have city 1 at 41 north, 112 west, city 2, 35 north, 91 west, and we're trying to find the middle. Okay. Best way to find the middle of those two numbers is to find the average, so 41 plus 35 divided by 2. And that comes out to, cheat sheet so I don't have to type it all in. Okay, so 41 plus 35 is 76. 76 divided by 2 is 38. 38 north. And then the middle of these two, again, just add them and divide by 2. Comes out to 203 divided by 2 is 101.5. We're done. Okay, next. 26. Calculate the area of the shaded region. These have been coming up for a while. I know they used to be on like 4th and 5th grade curriculum too. To find the shaded region, you just take the area of the larger shape and then subtract the smaller. So that's what we're going to do. Area of large triangle minus area of small triangle will give us the shaded region. Okay, the big one right here. Area of a triangle, again, area equals 1/2 base times height. So 1/2 37.3 times 37.3 minus 1/2 23.5 times 23.5. And then we solve. This solved out comes to 695.645 minus 276.125. And as far as doing 1/2 in the calculator, multiplying by 1/2 is the same as dividing by 2. So once you multiply those two numbers, just divide by 2 to get this number. Then the subtraction problem, we have 419.52 meters squared. Okay, next, what type of compass and straight edge construction is being made in this diagram? Okay, we have original angle, and then they construct an angle just like it. So, congruent angles. Next, this one's from the quarterly assessment review too. Copy the angle. How would you construct an angle that has a measure of 1/4 the measure of the given angle? Explain your reasoning. Oh, okay. Have a good one. Okay, to find one that's 1/4, we could bisect it to find 1/2 and then bisect it again to find 1/4. How this construction would look is you'd use the compass to make an arc like this. You won't actually have to use the compass, just understand the idea. And then from this, you'd put the compass here and make a mark, and from this point, make the same mark. So this would then bisect the angle into half. And then from there, you would do the same thing, but with the half. So if you put a point right here, and then put the compass here, made a mark, and then put the compass here, made a mark, then you could break it into fourths. So the answer is you could bisect the angle twice. Bisect the angle twice to get 1/4. Okay, next. And on the next page, you may have seen these questions actually in the homework yesterday, so they should be kind of familiar. Number 1, it says if a rectangle ABCD is reflected across the x-axis, the measure of the length and the width of the rectangle will be changed. Wait a second. Okay, so here's xy axis, x, y. They're saying you have a rectangle and it's reflected over that x-axis, and they're saying the dimensions change. No, the dimensions stay the same with a reflection, so that is false. Number 2, a 90 degrees clockwise rotation of a circle. When we did rotations, we didn't really work with circles, but same rules apply. Okay, so let's say I have a circle right here. Okay, it's rotated 90 degrees about the center. Okay, so the new circle is right here. Will result in a circle with the same radius? Yes, but a different center point. True, that is true. It does have a different center point, but it should be the same exact circle. Okay, in the diagram, it says NP is congruent to OQ. What additional facts are needed to prove that these two triangles are congruent? Well, we know that this is equal to this because of reflexive property. Looking at the answer choices, I'm going to skip the first one because the first one's actually the correct answer, but I want to show why these aren't right. So this one says that NOP, this angle is equal to QOP. Well, those angles aren't even equal, so that's not right. Then it says that Q is equal to N. If we knew that Q is equal to N, then you'd have ASS, which isn't a congruence statement. And then NO equal to NP. Well, NO and NP aren't equal, so that's not correct. The only thing that would work is you'd have to know that NP is parallel to this line. And if you knew that, then alternate interior angles would be equal. And then you have side angle side, side angle side. So that is why A is the correct answer. Number 4, given the diagram below, AB is congruent to BC. They mark that for us. Cool. What other information would be needed to prove that these two triangles are congruent? Well, this would be equal to this because of reflexive. We need to know that this angle is equal to this one to have side angle side. So that's what I'm looking for. ABP is congruent to CBP. It's that first answer again. The other ones probably identify different angles, like BAP, this guy, and BCP. No. Okay, so it's the first answer. Then number 5, it says in the diagram below, given MN is the mid segment. If MN is the mid segment here, then this is a midpoint and this is a midpoint of the segment. It says the measure of CD, so this whole thing here is 10 units. What is the measure of MD? So it wants to know this guy. Well, if this is the midpoint, then MD would be not 10, it would be 5. It would be 5. So C. Next, in the diagram below, given that MP is a mid-segment of SQR, so it's saying MP, just identifying what they're talking about. It's a mid-segment of SQR. The measure of PQ, this right here, is 10 units. What is the measure of SQ? The whole thing? Be 20. And that's it. So I'm going to have you get a laptop, get logged on to Schoology, do the homework assignment per usual.